Hello student, welcome to my official YouTube channel Mathematics All Levels. And today I have started one series in which I'll be discussing about the previous year important questions of exponential and logarithmic functions. So today the question which I have taken, the first question which I have taken is based on the base change. So this where majority of the student gets stuck in changing the base. I'll tell you how. So the question I've taken is log x base 3 negative of log 4x base 9 equals to 1. So how to approach this question? I'll do it for you directly. Log x base 3 negative of log. Now this 4x, the base here in the second logarithm log is 9 and the argument in the second base is 4x. Now this 4x, how this could be written? This 4x could be written in 2 root x whole square. This argument could be written like this, equals to 1. Similarly, again I'll write this for you, log x base 3 negative of log. Now the base of the second log is 9. Now the 9 could be written in the form of 3 square. And the argument I have already written, it is 2 root x whole square equals to 1. Okay, so why I'm doing this? Because we know that we know the law of the logarithm, that power get into the fraction form and it will become it will come outside as a multiplier. So here from here the argument power is 2, so this power will come out, and the base power is 2, so it will also come out in denominator. So this log, now argument will be 2 root x and the base here will be 3 equals to 1. Okay, the person who is not getting that what I am using here, student, is the format of this. Log m b power is p, and for the base the power is q. So this could be written as p by q log m base a. Okay, this is the form of logarithm which we have used here. One of the laws of logarithm. This is the important laws of logarithm which I have used here, students. So let's proceed ahead. Yeah, so now we can see here that this got cancelled and we will be left out with log x base 3 negative of log 2 root x base 3 equals to 1. Now applying the quotient law here, we'll get log x by 2 root x equals to 1 and the base will be 3. Okay, after doing it further, we'll get x by 2 root x equals to, on expanding it in exponential form, so it will be 3 raised to the power 1. Okay, now I'll be solving it here. Yeah, so what we left out with, x by 2 root x equals to 3. Okay, now what we need to do, we need to we can square both the sides, or we can cancel out the term here itself. So if we cancel out the term, so we'll left out with root x upon 2 equals to 3. This will be left out with. Now on squaring both the sides, what we'll get, x by 4 equals to 9. I have squared both the sides. Okay, students. So what we have got, x by 4 equals to 9. So on solving it further, we'll get 36. So this is the solution, student. This is our solution. Okay, so this is the base change barrier where majority of the student gets stuck. So this is how we need to proceed it. Okay, I've solved it for you. Now let's take another questions where student get stuck, is the substitution method and the hidden quadratics. I'll tell you how, what I meant. So for example, this is the question I've taken, 3 log x base 3 whole square plus log x raised x, the argument power is 5 and the base here is 3. Negative of log 9 base 3 equals to 0. Okay, so If I write this as log 3 log 3x whole square plus of this, applying the reverse of power law, so the 5 will come out, it will act as a multiplier. So log x base 3 negative of log, this argument here is 9, so we could write it as 3 square base is 3 equals to 0. On solving it further, we'll get 3 log base 3x whole square plus of 5 log x base 3 negative of, this could be written as 2 log 3 base 3 equals to 0. Okay. Power law, we have applied the reverse of power law here in this part. So this could be written. Now we know that log 3 base 3 will be 1. So, and we need to substitute here. Let's say, let log x base 3 equals to t. Okay. So what we'll get on placing it in this equation, we'll get 3t square plus of 5t negative of 2 equals to 0. So I have directly written 2 here because log 3 base 3 will be 1. Okay, so on calculating it further, we'll get 3t square. We'll be factorizing it here. So we'll get 6t negative of t negative of 2 equals to 0. So we'll take 3t as common here. So we'll left out with t plus of t 2 negative of 1. I've taken negative 1 common here. In the third and fourth expression, we left out with t plus of 2 equals to 0. So from here we know that we are having t plus 2 as common in whole equation. So we'll be taking t plus 2 as common. T plus 2, 3t negative 1 equals to 0. From here we can say that the value of t could be negative 2 and it could be 1 by 3. Okay, so what we have supposed here, student, the first part student here is that we'll be substituting t equals to negative 2, and the second part student here will be that we'll be substituting t equals to 1 by 3. Okay, so now let's solve this part. On substituting t equal to negative 2, so log x base 3 is equals to negative 2. So from here on expanding it in the exponential form, we'll get 3 raised to the power negative 2. So it could be written as x equals to 1 by 9. Okay. So this is the solution when t was equals to negative 2. And for t equals to 1 by 3, again we need to substitute our given value, that is log x base 3 equals to 1 by 3. So on calculating it further, on expanding in exponential form, so we'll get 3 raised to the power 1 by 3. Okay, student. So yeah, so this is our value, student. So this is our value. X equals to 1 by 9 and x equals to 3 raised to the power 1 by 3. Okay, so these two solutions are possible. So you came to know that how we need to substitute the means log x base 3 and how we need to convert into it into the quadratic expression. So this is the major challenge here, student, which student faces. So yeah, so let's move ahead. Okay, student, so the next question which I have taken is the barrier for the student because they faces the negative argument as an exam trap. So the question here states that we need to solve log x plus 3 base 2 plus of log x plus 10 base 2 equals to 2 plus of 2 log x base 2. In the left hand side, what we can do, we can analyze that the base here is 2, so we will directly apply the product law. So for this we will write log of product law, so the argument will get multiplied here. So x plus of 3, x plus of 10, and the base will be 2 here, equals to, now see this 2, this 2 could be written as, 2 log 2 base 2. Okay, and it will not affect my value because log 2 base 2 will be 1. So for this, what we'll do, we will write it as 2 log 2 base 2 plus of, we'll apply the reverse of power law here. So you'll get log of x square base 2. Okay. Now left hand side will be written as it is. Here we'll expand the argument here. So we'll get x square plus of 13x plus of 30 equals to, here we'll apply the reverse of power law in the first term. So it will be log of 2 square base 2 plus of log of x square base 2. Okay. Now again I'm writing the expression here. Left hand side will be written as it is. Here we will apply the product law. So we'll get log of 4x square base is 2. Now we can analyze here that the bases on both the sides are equal. So it means the argument will be also equal. Okay. So what we'll do, we'll directly make the argument equals. So it will be x square plus of 13x plus of 30 equals to 4x square. On transposing this left hand side to the right hand side, what we'll get, 3x square negative of 13x negative of 30 equals to 0. Okay. Now from here we can factorize this expression, and even also we can apply the quadratic equation formula. So on factorizing it further, we'll get 3x plus of 5 negative into x negative of 6 equals to 0. Okay, I factorized this expression. Factorizing is easy. If you want to use the quadratic equation formula, you can do it. Otherwise, you can directly factorize by taking the first term of the coefficient of x square and the last term, and then multiplying it, and then taking the factors of it and adding or subtracting it in such a way that we get negative 13 in the middle term. So by this we can see we have got the value as 3x plus of 5 cross x negative 6 equals to 0. From here, what the potential solution will be, 3x plus of 5 will be 0 and x negative of 6 will be 0. For this it will be x equals to negative of 5 base 3 by 3, and for x, this equation, x will be 6. Okay, so we have got two values, student, that is x is equals to negative 5 by 3 and x is equals to 6. Now see what the negative argument mean here. Now we'll be coming on this part. So for first case is x is equals to negative of 5 by 3. Okay, now what we need to do, we need to insert these values, insert x equals to negative 5 by 3 in the argument of this function, of this log and of this log, and similarly for this log. Okay, so if I substitute x equals to negative 5 by 3 in the argument of this first log, so we'll see that negative of 5 by 3 plus of 3, it will be greater than 0. Means the argument should be positive. We know this part, that argument of a log should be positive. Okay, so we can see that on substituting negative 5 by 3 in this argument, we'll get negative 5 by 3 plus of 3, that will come greater than 0. Similarly, if I substitute negative 5 by 3 in the argument of second log, this I'll be writing in first log, this will be writing second. So here we see that negative of 5 by 3 plus of 10. Again, we can analyze here that it is also positive. Okay, this is positive. This is also positive. Okay, student. Now let's come for this log. This is the third log in our equation. This is third log. So if I substitute it here, so what we can see that it will be log of negative 5 by 3 base is 2. So this is not possible because the argument should be greater than 0. It should be positive. So hence this x equals to negative 5 by 3 could not be a potential solution for this equation expression for this equation, students. Now the second part is if I substitute x equals to 6. For x equals to 6, now we need to insert this x equal to 6 in the first log which I have mentioned here. So we can say that it will be positive because 6 plus of 3 will be greater than 0. Similarly, for second log, it will be 6 plus of 10, which will be greater than 0. Now we'll substitute x equals to 6 in this third log. So what we can see that log of 6 base 2, it will also be greater than 0. Okay, it will be greater than 0. So we can say from here that it in all the log this log on inserting the value of x equal to 6 in all the three, so we can say that all we are having positive solution. So this will be the potential solution for this expression. Okay, so the x equals to 6 will be the only solution possible. So what majority of the student will do, they will mark this as also solution. Okay, so this is our only solution, students. So hope you like my video. Thank you.